So like I was mentioning, we can use matrices to solve this real world problem, in which again we have tapes, LPs, and CDs being sold at $8, $6, and $13 per item respectively. And this matrix here shows us the amount of items that were sold, again of tapes, LPs, and CDs respectively. Well, we know how to solve this using arithmetic, which would be multiplying the price of the tapes by the number of tapes, added to the price of the LP times the amount of LPs sold, added to the price of each CD times the number of CDs sold, and that will give you the gross income, which is what we're trying to find. But essentially what you're doing is you're multiplying the matrices. So let me rewrite the matrices here without a unit. So in this matrix, we only have one row. Remember, we multiply row by column. Here we only have one row. Here we only have one column. So we are going to multiply the elements in the row times the elements in the column, and we're going to add them, which means that my matrix will look as follows. 8 times 9 plus 6 times 30 plus 13 times 20. And when I add all of this up, I'm going to see that what I'm going to get is, well, I have 8 times 9, which is 72. I have 6 times 30, which is 180. And I have 13 times 20, which is going to give me 260. And when I find all of this, I'm going to get 512. Which again, considering that this is a real life problem, we're going to have a real life answer. My gross income is $512. Okay, so I hope you noticed something a little interesting with the dimensions of the matrix. So here we have a matrix that is 1 row 3 columns, so this is a 1 by 3 matrix. And here we have a matrix that is 3 rows 1 column, so this is a 3 by 1 matrix. And when we multiply it, our answer is just a matrix with one element. It is a 1 by 1 matrix. Well, there's something really interesting here, which is that the product of matrices A and B, so any two matrices, can only be found if the number of columns in matrix A equals the number of rows in matrix B. Well, let's see. The number of columns is represented by the second number, 3, matches the number of rows here, 3. Notice it has to match. They are not equivalent, they correspond. The number of columns here represent the tapes, LPs, and CDs, and that's exactly what the number of rows here represents. So they have to match in order for me to be able to multiply them. The number of columns match the number of rows. Not only that, but if you see here the dimensions of a product matrix, if the number of columns in the first matrix match the number of rows in the second matrix, then I am allowed to multiply them. And not only that, but the dimensions are as follows. So if A is an m by n matrix and B is a n by p matrix, then the product of matrix AB is m by p. So just to make it a little nicer, AB would be an m by n matrix times B, which is an n by p matrix. I know I can multiply them because the number of columns match the number of rows here. N equals n. My inside numbers match. Good. They're equal, so I can multiply them. And my matrix is going to be the sum. So it's going to be m by n matrix. M by p matrix, which is exactly what it says here. So if we see this with the matrix we just did, it's absolutely true. We have a 1 by 3 matrix multiplied by a 3 by 1 matrix, right? That's exactly what we did. Well, 3 and 3 equals the number of columns here match the number of rows in my second matrix, so I can multiply them. And my dimensions will be 1 by 1. Which is exactly what we had here, a 1 by 1 matrix. So now I want to do an example which we determine whether a product matrix exists. So I see here that I have matrix G and matrix H. We have 3 rows, 2 columns. This is a 3 by 2 matrix. Here we have 2 rows, 2 columns. This is a 2 by 2 matrix. And I'm asked to determine whether matrix GH and HG are defined or undefined. Defined meaning I am able to multiply. Undefined meaning I am not able to multiply these matrices. And like I mentioned, what determines whether it is defined or undefined? What determines whether I can multiply them or not? If the number of columns in matrix A, meaning my first matrix, and here it's G and here it's H, match the number of rows in my second matrix. So let's see, GH, that would be 3 by 2 times 2 by 2 matrix. Do the number of columns match the number of rows? Well, my inner values are the number of columns and rows. So yes, they do match. So it is defined. Okay. Let's see for HG. For HG, I would have, H is my first matrix. I'd have a 2 by 2 times a 3 by 2. Let's see. Do the number of columns in my first match the number of rows? It does not match. Meaning it is undefined. I cannot even multiply these matrices. It's not defined. If I do multiply GH, what would my dimensions be? Well, since I am able to multiply them, it's going to be the number of rows in matrix A, in this case matrix G, my first matrix, by the number of columns. So this is going to be a 3 by 2 matrix. Okay, so this is how you determine if matrices are able to be multiplied. And you have your different matrix properties, which is the closure property, associative property, distributive property, multiplicative property, which you can refer to the book for more notes on those, but the properties are essentially very similar to the properties that we learn with real numbers. And that's all.